is we are going to start by reviewing all of the exponent laws that you should have written down and noted in the e-learning day from a lesson from Monday. Oh, goody.
I looked at the first page and like I tried to do this.
So these are our rules. The first rule is that if I'm multiplying two terms with the same base with different exponents, it becomes that base with the exponents added together. So the example here is x to the a times x to the b is equal to x to the a plus b power. So we just add the exponents when we multiply the bases. The second rule is if I'm dividing two of the same base with different exponents, that becomes that base to the top exponent minus the bottom exponent. So the example we have here is x to the a over x to the b is equal to x to the a minus b power.
That one's going to be smaller than the bottom. We're going to have a negative exponent.
Yes, but then we'll learn how to change it in a minute. The other one is if I'm taking a base and an exponent and raising it to another exponent. So here x to the a all raised to the b power. That is equal to the same base with the exponents multiplied together. So x to the a all raised to the b becomes x to the a times b power. That's a little bit. The fourth rule, which to me is the easiest to remember, is anytime I raise any base to a power of 0, the answer is 1. Always. Doesn't matter. Anytime you have an exponent of 0, unless the base is 0 as well, which is impossible, it is 1. Okay, and the last rule deals with our negative exponents. So if I have an exponent of negative a, that is the same as having x to the negative a over 1. And this negative indicates that I flip my fraction or move it to the opposite side of the fraction and it turns positive. So because I had a negative a exponent in the numerator, when I moved it to the denominator, it became a positive a exponent. This is negative exponents. Correct. We can have a negative base and it doesn't have to move, but anytime there's a negative exponent, it does. So what we're going to do today is just a bunch of examples using all of these exponent laws and simplifying until there are no negative exponents present in the final answer. So let's do the first example. The first example is a to the negative 1 times 2b cubed, all raised to the power of 2. I will tell you that moving exponents is typically the last thing that we do. So I like to work with the exponents as is to begin with, and then we'll move at the end. So the first thing I would try to do here is I would look to simplify anything inside of the parentheses that I could put together. There is nothing inside that I can put together because my bases are different, which means then I have to deal with the two outside of the parentheses. Because this is an exponent to an exponent, the 2 is going to go to all 3 terms that exist inside of the parentheses. When they multiply in, they're going to multiply by the exponent that's already there. So this becomes a to the negative 2, because negative 1 times 2 is negative 2, times 2 to the 2. So it goes to all 3 of these terms, and then times b to the 3 times 2, which is 6.
Wait, I thought it was addition, not.
It's addition if we're multiplying inside. So if I'm just multiplying these 2 terms together, I would add the exponents, but because it's a power to a power, it's multiplication.
Well, I pretty much filled the homework I did yesterday.
Yes, Brandon.
So it doesn't become 2a, it just goes.
No, because 1 to the 2 is still just 1. So that's why it only goes to each of the terms individually. Brandon asked, why doesn't it go to the 1 in front of a? Because 1 to any exponent is still just 1. So it doesn't impact it at all. So we just pretend there's nothing there. So then from here, I would just go ahead and simplify it a little bit more. So this becomes a to the negative 2 times 2 squared, which is 4. And then I have b to the 6. There's nothing else I can simplify. So my last move is actually to change that a negative 2's position so it becomes a positive 2 in the exponent. So because it's in the numerator, it has to move to the opposite side of the fraction, which is going to be the denominator. So this becomes 4b6 over a positive 2.
Positive, you combine it with the 4b6.
No, because I can't put a's together, a's and b's together. So then we're done. This is our final answer for this problem.
Because for like the last four thing, I just put together, I put like 4a squared.
Oh, then yes, that's fine.
Okay.
If it was positive, I would have done that. Yes. How do we feel about that? Let's do another one. Two m cubed n negative 2 all to the 0 power times 2 m n to the negative 4. Give you a second to write this. What is the first thing I notice that I can do? I have a, what do you mean I have a 0, Brandon? I have a 0 exponent, which means that everything inside of whatever I'm raising to the 0 power is going to turn into what? 1, because it was all raised to that 0 power right there. So this becomes 1 times 2mn negative 4. We know 1 times 2 is just 2, so we can kind of just get rid of that altogether. I cannot put the m and the n together because they are different bases. I also can't combine the 2 with anything else because there's no other numbers, which means my last step is just to make my negative exponents positive. So what base here has a negative exponent on it? N. This n then is the only thing that I'm going to be moving. I'm not going to move any number in front of it. I'm not going to move any other base in front of it. The only thing I move is the thing that has the negative exponent. So where am I going to move that to? The underneath part of the fraction, and then it becomes positive. So I just like to tell kids, when it crosses the fraction bar, it changes signs. Because it was negative, when it crossed, it turned positive. And then that's it. There's nothing else I can do there. How do we feel about that? Not too bad? Let's do another one. This is 2vu to the negative 2 over uv cubed times u0v negative 1. This is a fun one for sure. Anybody have an idea of where we can start? Okay, I think I heard the same thing, just said 2 different ways. I have a u to the 0, right? Do we all see that?
Yeah.
What do I know is going to happen to the u to the 0? It's just going to turn into a 1, and 1 times anything is just that thing. So it's kind of like it cancels out. It just goes away. There's nothing else I can do with it. Everyone okay with that? So then what I like to do from here is I like to move my negative exponents to where they need to be so that I can combine them with any other similar bases that are there. So in the numerator, is there anything that I can combine before I move it? No, I have a 2 which can't combine with anything. I have a v which isn't combining with anything, and I have a u which isn't combining with anything. Do I have any negative exponents in that numerator? Yes. Which base? The u. U negative 2 here has to move because it currently has a negative 2 exponent. So when it moves, it's going to move to the bottom of the fraction, and it's going to become u positive 2. So I canceled it out from the numerator and just moved it to the denominator so it was positive. Are we all okay with that? So then I look in the denominator. I know I'm going to have some things that I can simplify and put together. So I want to focus on those things first. Sorry, Hannah, say that again.
Why did that move down?
Because I had a -2 exponent and I can't mess with things unless they're positive. So I had to move it so it turned into a positive exponent. So then down here, is there anything I can put together? Do I have any like bases? The two u's. I have u2 and I just have u. What exponent do I assume is on that second u? 1. So when I put them together, they're going to become what? U to the third, because 2 plus 1 equals 3. So what I have right now is 2v, and then I have u cubed. Is there anything else I can put together in my denominator? The v's, right? I have a v cubed and I have a v negative 1. So when I add their exponents together, it's going to become what? v2, good. So I have a 2v over u cubed v squared. This looks beautiful. Am I done? No. I have a repeating base. So we're done when there are no negative exponents and there are no repeating bases. I have a v in the bottom and I have a v in the top. So that's called a repeating base. I have a base v that exists in 2 places. That can't happen. Hold on. So then the way we fix this is we need to combine those 2 v's. What do I know I can do with the exponents if I have a base on the top and bottom of a fraction? What property? I had a property that says I can subtract them. So anytime I'm dividing where they're on separate sides of the fraction bar, it turns into division, or not division, subtraction, sorry. So the way we do this is we pick the one that's biggest and we move the one that's smallest. So if I'm looking at these 2 v's, which one has the bigger exponent, the top or the bottom? So that's the one that stays. The one on top then is the one that moves, and I just subtract it from the bigger one. I subtracted a 1 because it was a single v with no exponent, so we assume it had an exponent of 1 on it. Yeah, we pick the biggest one, and that's the one that stays. So then from here, I just go ahead and simplify. So this becomes 2 over u cubed v to the 1, or just v, depending on how you want to write it. And then we are finished. How do we feel about that one? Rough? Not great. This is why we're doing 2 days. Going to get through all the examples today, give you time to look at the homework, and then tomorrow we can address any issues that you're having. It is a lot of work. So let's go ahead and move into our last 3 examples, because that's all that's left. We got this. Come on. The next example I have is v0 y cubed times 2xy negative 3 over 2xy squared all to the negative 1 power. Okay, so the v0 is going to be the first thing to go because that turns into a 1. Is there anything else I can put together in my numerator? The y's, right? I have a y3 and I have a y negative 3. So when I add those together, what does that become? Becomes 0, right? Because 3 minus 3 is 0, and y0 is going to equal 1. So those cancel each other out. And then the 2 can't combine with anything, and the x can't combine with anything, so those stay in my numerator. Then I look in my denominator. Is there anything inside of the parentheses that I can put together? No. But I do notice that my entire parentheses is being raised to what power? -1. So a negative exponent tells me this thing has to move. So that means this entire parentheses is going to pick up and move to the top of my fraction because it currently exists in the bottom. And then it's all going to be raised to the +1 power. So I just picked that whole thing up and I moved it, and the -1 exponent became a +1 exponent. I know anything to the 1 power is just itself. So this is the same as 2x times 2xy squared. And now I can just combine like terms in that numerator. So I'm going to put the two 2's together, right? What's 2 times 2? I can put my two x's together. x1 and x1 become what?
X2.
x2, yep. And then my y2 can't combine with anything. So my answer is 4x squared y squared. Was that one a little bit better than the last one? Okay. Give you guys a second to finish writing, and then move on to the second to last example. Okay. So the next example we're going to do is v cubed over 3u to the -3 times 4u to the -2. So I like to simplify in my numerator and my denominator first before I start moving stuff across my fraction bar. In the numerator, is there anything I can put together? No, there's nothing else up there, so it can't combine with anything else. So that's going to stay. In my denominator, is there anything I can put together?
The 3 and 4.
The 3 and the 4, what's that going to combine to become, Ebony? 12. Is there anything else I can put together? The u's, right? They have the same base, which means I can put them together. When I put them together, I add the exponents. So what's u -3 and u -2 become? U -5, because -3 plus a -2 is -5. Are we all okay with that part? I know I'm not done because I still have a negative exponent present in my problem. So that u -5 is going to have to move. Where's it going to move? To the top of the fraction. Is the 12 going to move with it? No. The answer is no. No number moves with it, only the base and the exponent. So that whole thing is going to move, and it's going to become u to the +5, v cubed over 12. And that's your final answer. How do we feel about that one? Are they getting easier at all?
They're very complex.
They are, which is why I'm trying to not overwhelm you, and we're going to take it a little slow. So we have one more, and this is the last one we're going to do today, and then you're going to have homework time. Okay? So this last one has the numerator x squared y -2 over 2x to the 4th y squared times 2x to the -4 y -4 times y cubed, all to the -1 power. So what I like to do first, of course, is I like to simplify the numerator and the denominator individually. I think it makes it a lot easier to work with. So looking at the numerator, is there anything I can put together or combine? No. So that's going to stay. There's nothing I can do with that right now. So I'm going to have x2, y, -2. We're all okay with that. Is there anything I can combine in my denominator? Pete, what's the first thing I can combine? The 2's. I have a 2 here and I have a 2 here. They can combine to become 4. What else can I put together?
All of the Y's.
All of the y's. So right now I have a y2, a y -4, and a y3. So I need to add all of those together. So 2 minus 4 is -2, plus 3 is +1. So that becomes y to the 1. Can I put my x's together as well? Yes. Emily, what is it going to become when I combine x4 and x -4? Just x to the what power?
0.
Okay, it becomes x to the 0 power because 4 plus a -4 becomes 0, and x to the 0 is just 1, so I can actually just cancel those out completely. And then all of that is raised to the -1 power still. I'm not done simplifying inside of that parentheses, right? I still have a y on both sides of my fraction, and one of them is negative. So I know right away that I need to move that -1, correct? Where's it going to move to? To the bottom because it's currently in the top. And when it crosses the fraction bar, the -2 turns into a +2. Which means that, again, I can put those y's together. And this becomes x squared over 4y cubed, right? Because 1 plus 2 becomes 3. And then all of that is now raised to the -1 power. Are we all okay so far? Anna, do you have a question, honey? Okay. So then my last step, since I've simplified on the inside, is to address the exponent on the outside. What is that exponent? -1. So this is very unique when I have a fraction on the inside. It means everything from the numerator is going to move to the denominator, and everything from the denominator is going to move to the numerator. So my fraction is literally going to flip over. So then this becomes 4y cubed over x squared, all raised to the +1 power, which is just 4y cubed over x squared. And then I'm done. How do we feel about this? It's a little rough. I know it is. That's okay. So what you're going to do now is you're going to take the rest of the class to work on the homework that's posted on Canvas. I'm here, obviously, if you have questions for me. And then tomorrow, we are going to go over some of those questions, and we're going to address the issues that you guys have. Okay? So this homework is actually going to be due on Monday. That doesn't mean you should not work on it. We have plenty of time right now for you to do so. And then tomorrow in class is the time for you to ask some more questions about it. Okay? So those of you online, obviously, if you want to, you can hang out and work on the homework. If not, you're welcome to log off, but make sure you work on that and you come to class with questions for me tomorrow.